Hello, this is Mrs. Ward, and I'm going to go over the review for the 6364 sections, which are covering vectors. So, number one, in your own words, explain how you find the component form of a vector when you're given 2 points, and where is the initial point of the vector in component form. So, I always say terminal minus initial. And so your book uses this PQ thing like that. If I have a vector that goes like this, and this is going to be my x2, y2, and this is going to be my x1, y1, because that's where I start, that's where I end. Then to find the component form, you're going to take x2 minus x1, comma, y2 minus y1. And when you do that, what happens is you pick up that vector and you put the initial point. The initial point now becomes at the origin, or the initial point is now at 0, 0. And that's why we do it, is to put the vector at the origin. Number 2, let W be a vector with an initial point of 2, 5, a terminal point of negative 3, 8. So I'm going to take terminal, negative 3, minus initial, terminal minus initial, and then I put the brackets to show that I am putting in a vector form. So I'm going to have negative 5, positive 3, and that's in component form. So it's like I'm picking up that vector and placing it so that it starts at the origin. Number 3, in your own words, explain what the magnitude of the vector measures. So in my own words, magnitude measures the length of that vector. So it tells me how long it is. When I do application problems, that measure is going to be either the speed of the airplane, or it's going to be the force that gravity is pulling on my truck on the hill. How do I find the magnitude of the vector? So if I have not changed it and I have an initial point and a terminal point, I'm going to do the distance formula where I take x2 minus x1 squared plus y2 minus y1 and square it, and that's how I'm going to find the magnitude. If it's in the component form where I have that AB and I'm already in the component form, then the magnitude is just going to simply be a squared plus b squared. So it does change, but usually I recommend everyone put it in the component form before they find the magnitude. Just makes life a heck of a lot easier. Number 4 is find the component form and the magnitude of the vector v. So I have this lovely little picture here. I can see that the arrows here, which makes that the terminal side, making this side the initial side. So I'm going to do terminal minus initial. So I'm going to say negative 7 minus 5, and then 5 minus negative 3, and when I do that, I get negative 12, 8. That's the component form. Now to find the magnitude, I'm just going to do this. So the magnitude of v, remember those double lines mean magnitude, is going to be the square root of negative 12 squared plus 8 squared. And when I do that, I get the square root of 208. I could leave it like that. Or I know that 208 is 16 times 13, so square root, and I get 4 times the square root of 13. Either one of these answers is acceptable. Not a decimal though. Number 5, find the magnitude of v if v is equal to negative 5, 4. This is an easy one because it's already in component form. I just have to take negative 5 squared plus 4 squared, and when I do that, I get the square root of 41. 41 is a prime number, so I cannot factor it, so I'm just going to leave it as a square root of 41. No decimal. Number 6, given the vectors 2, 7, and negative 3, negative 2, determine the quantity of negative u plus 5v. So I'm going to do negative u, so negative times this 2, 7, which would be negative 2, negative 7, just distributing that negative sign. And then I'm going to have plus 5v. So multiplying those by 5, I'm going to get negative 15, negative 10. And then when I add them, I'm going to have negative 2 plus a negative 15, negative 7 plus a negative 10. And my final answer is going to be a negative 17, negative 17. On something like this, I would take my time to show all my work so I don't make a silly addition or subtraction mistake. Number 7, given that u is equal to 2, 6, and v is equal to 3, negative 1, find u dot v. U dot v means the dot product. So to do the dot product, I'm going to take 2 times 3 plus 6 times negative 1. So I'm going to have 6 plus negative 6, and I'm going to get 0. Remember, when I do the dot product of two vectors, I end up with one number called a scalar. So I have this 0. If I ask, which it doesn't, since I didn't get a 0 for my dot product, I know that these two are orthogonal. In other words, they form a right angle with each other. But it didn't ask me that, just thought I'd tell you that. Number 8, what is the magnitude of a unit vector? Well, the word unit means 1. So the magnitude of a unit vector is 1. And number 9, find the vector v that has a magnitude of 3 that is in the same direction as negative 3, 3. So to do this, the first thing I'm going to do is find the magnitude of u that I'm given. So I'm going to find the magnitude of this. So I'm going to take negative 3 squared plus 3 squared. And when I do that, I get the square root of 18. And I'm wondering if you left it like that. If you left it like that, let's leave it like that for right now. Then now what I'm going to do is I'm going to knock this one down to a unit vector. So to knock that down to a unit vector, I'm going to take the two components, negative 3 and 3, and I'm going to divide them by the square root of 18. And that would be my unit vector. Now I want it to have a magnitude of 3. So I'm going to multiply this unit vector, which now has a magnitude of 1, and I'm going to multiply it by 3 to give it a magnitude of 3. So I'm going to throw that 3 out here. And when I do that, I get negative 9 over the square root of 18, and then 9 over the square root of 18. You can leave your answer like that, or the square root of 18 is 9 times 2, square root, so 3 times the square root of 2. So I could have had negative 9 over 3 times the square root of 2, 9 over 3 times the square root of 2. They'll simplify. The 9 and the 3 will simplify. So this will end up being negative 3 over the square root of 2, and then positive 3 over the square root of 2. So that's just if I simplify. Again, either one of these answers is fine. Number 10, find the projection of u onto v. So u is equal to 2, 3, v is equal to 3, negative 1. So I'm going to find the projection of u onto v is going to be the dot product first over the magnitude of v times the vector v. Ooh, wrote it like that, my bad. All right, so I'm going to do 2 times 3 plus 3 times negative 1 all over the magnitude of v, so the square, magnitude squared. I knew I forgot something. So this will be 3 squared plus negative 1 squared, and this whole thing is squared, and then I'm going to multiply by the vector 3, negative 1. So this will be 6 minus 3, which will just be 3. And then this is 9 plus 1, which is 10, square root of 10 squared, so this will be 10. So 3 tenths times 3, negative 1. And then when I distribute, I'm going to have 9 tenths, negative 3 tenths. And that is going to be my projection of u onto v, which we call W1. Now, it doesn't ask, but I'm going to do. Usually you had to write this as the sum of two angles. So you want to rewrite u, which is 2, 3. I want to rewrite 2, 3 as the sum of this W1 plus some other vector, which we call W2. So to find that, I took this 2, 3 and subtracted this W1, or the projection of u onto v, to find my W2. W2, this sounds like tax time. All right, so then when I do this, I'm going to take 2 minus 9 tenths which ends up being 11/10. And then, so the 2 minus 9/10 was 11/10. And then when I take 3 minus the negative 3/10, I get 33/10. And this is going to be my W2. So I could write 2, 3 as the sum of 9/10, negative 3/10, plus 11/10, 33/10. And you could do a real quick check to make sure that works. And that's how I find the projection of u onto v, and that's how I write u as the sum of two vectors. Number 11, find the magnitude of v with an initial point 1,5 and a terminal point negative 2,7. So I'm going to take terminal, so negative 2 minus 1, and then 7 minus 5. And when I do that, I get negative 3, positive 2. And it wants the magnitude. So so this is v, and then to find the magnitude of v, I'm going to do the square root of negative 3 squared plus 2 squared. And that's going to be 9, 4, 13, square root of 13. Now, I didn't have to put in component form first. I could have done the distance formula to find the magnitude, but I find it a lot easier just to find the component form first. Number 12, I want to find the magnitude and the direction angle of the vector v, which is negative 3, 4, round the direction angle to the nearest degree. So to find the magnitude, I'm going to first think of this in component form, looking at the coefficients. It's going to be negative 3, positive 4. That's the coefficient of I, coefficient of j. So the magnitude is going to be the square root of negative 3 squared plus 4 squared. And when I do that, I get 5. It ends up being the square root of 25, which is 5. Now to find the angle, I'm going to do the tangent of theta is equal to b over a. So I personally like to do the inverse tangent. So I'm going to do the inverse tangent of 4 over negative 3 is equal to theta. If you're an n-solved person, that's fine. Still respect you, but I'm going to do it this way. When I do this and I change it to degrees, I get theta to equal a negative 53.1 degree. Then I like to go back and make sure that that makes sense. And every time I find an angle, I like to check and make sure it makes sense. So I'm going to go back up to my vector. My vector is negative 3, positive 4. So I'm going to the left 3, up 4. So if I drew a picture of my vector, this is what my vector would look like in component form. So that's my vector. I clearly see that my vector is in the second quadrant. When I come down here to this angle, negative 53.1 degree, if I were to draw that in trig class, here's where 0 is, negative 53 degrees would be down in the fourth quadrant. Well, obviously my angle does not match the quadrant that my vector is in. And that happens when my vector is in the second or third quadrant. The simple adjustment is I just take whatever angle I had, which was at negative 53.1 degrees, and I add 180 degrees. And what that's going to do is it's going to just take me halfway around the circle, which is where I want to be. And when I do that, I end up with 126.9, but then I read the directions and it says to the nearest degree, so I'm going to round that to 127 degrees. Okay, number 13, it says find the component form of vector v if the magnitude is 2 and the angle that it makes with the x-axis is 305 degrees. So I am going to take the cosine of 305 degrees, sine of 305 degrees, and that will give me the x and y coordinate on my unit circle, which has a magnitude of 1. Since I want this vector to have a magnitude of 2, I'm going to multiply that unit vector by 2. So on my calculator, and I'm going to do it all on my calculator in one straight shot, I'm going to take 2 times the cosine of 305, and I get 1.15. Take 2 times the cosine of the sine of 305 degrees, and I get a negative 1.63. And that is my component form of a vector with an angle of 305 degrees, magnitude of 2. Number 14, find the angle between vectors u and v if u is 3, 4 and v is negative 1, 2. So now I'm using that angle formula, which is the cosine of theta is equal to the dot product of the two vectors over the magnitude of u times the magnitude of v. So when I do this, I'm going to say the cosine of theta is equal to u dot v. So I'm going to take 3 times negative 1 plus 4 times 2, and that's all over the magnitude of u. So 3 squared plus 4 squared, square root of that, times the magnitude of v, which is negative 1 squared plus 2 squared. And when I do that, I have the cosine of theta is equal to, so this is negative 3 plus 8, so that's going to be a positive 5. The square root of 3 plus the square root of 4 will be the square root of 25, which is just 5. This will be 1 plus 4, so square root of 5. So that's what I have. And I can leave it like that. I can simplify the 5s. It doesn't really matter because I'm just going to throw it in my calculator. I'm an inverse person, so I'm going to do inverse cosine of 5 over 5 times the square root of 5. I did not simplify because it does not matter if I simplify. When I do this and I put this in my calculator, I end up getting 63.4 degrees. So the angle between those two vectors is going to be 63.4 degrees. Oh, it says round your answer to 2 decimal places. Whoopsie, I don't have the second decimal place. Sorry. All right, moving on. Determine whether u and v are orthogonal. Remember, the definition of orthogonal is when the dot product is equal to 0. So I'm going to find u dot v. So negative 2 times 6 plus 3 times 4. Remember, when you're doing a dot product between two vectors, you're going to get a scalar or one number. Negative 12 plus 12, and I get 0. So I'm going to say yes, they are orthogonal. Okay, number 16. One of our favorite problems is a plane problem. A jet is flying from Miami to Seattle. Oh, bad math. Those should be capitalized. So sorry for that, English teachers. The jet's velocity with respect to air is 600 miles per hour, and it has a bearing of 120. So I'm going to draw that 600 miles per hour and a bearing of 120. Remember, bearing started at 0, 180. So that bearing of 120 is going to be down here somewhere. This is 120 degrees for bearings. I have to find my trig angle, which means I have to find this angle right here. So I'm going to take 120 and subtract this first quadrant. So I'm subtracting that. And I get 30. So my trig angle is going to be 30, but since I'm going down, I'm going to make it a negative 30. So to find the component form of my plane, I'm going to take 600 times the cosine of negative 30 degrees, sine of negative 30 degrees. Let's do the wind. The wind is blowing from the southwest northeast 20 degrees. So this is going to be 20 degrees, which means that my trig angle is going to be from this being my positive x-axis up. So I'm going to take 90 minus 20 and get 70. So this is going to be 70 degrees, and it's going to be a positive 70 degrees because I'm going in the positive direction for trig. And it's going 55 miles per hour. So to find the component form of the wind, I'm going to take 55 times the cosine of 70 degrees, sine of 70 degrees. Now, since the plane and the wind are working together, I'm going to add these two. So when I take 600 times the cosine of negative 30, I get 519. 600 times the sine of negative 30, I get negative 300. 55 times the cosine of 70, I get 18.8. 55 times the sine of 70, I get 51.6. When I add those two, so the 519 plus the 18, I get 538. Negative 300 plus the positive 51, negative 248. So that is my resultant vector. So now I want to find the speed, and the speed is the magnitude. So I'm going to do the magnitude. So I'm going to take that 538.426, square it, and make sure when you're doing one, especially when you get larger numbers, that you put the negative ones in parentheses so you don't mess that up and you actually squared because it will be positive when you square it. When I do this, I get 592.93. My units are going to be miles per hour. Then when I do the next one, I want to find the angle. First, going to find my reference angle. So to find my reference angle, I'm going to do the inverse tangent. We're just going to skip to that step of my B over my A. And when I do that, my angle ends up being a negative 24.8 degrees. So in trig world, this is a negative 24.8 degrees. I need to find my bearing, so I need to find from here to there. So I have this 24 already accounted for. I need to add this extra 90. So my bearing is going to be 90 plus the 24.8, which is going to be 114.8 degrees, and that is my bearing. And the last one's a work problem. So to slide an object across the floor, a person must pull a rope with a constant force of 25, angle of 30, and the object is dragged for 40 feet. So remember, work is equal to the cosine of the angle times the force times the distance that you're traveling. And I'm just going to write distance. That makes sense to me. So work is equal to the cosine of 30 degrees. My force is 25 pounds, and my distance I'm traveling is 40 feet. When I multiply all that together, I did 500 times the square root of 3. Most of you don't have that. You have 866.25, and my units are going to be foot-pounds. And ends the review sheet. If you have any questions, let us know, and we will see you next time in class.